3.3 Using ratio tables. There are two terms that I would like you to know for this. So for the first one is it's a ratio table, which is just a table used to find and organize equivalent ratios. So get that written down. And then just to make sure that we understand what equivalent ratios are, they're basically just two ratios that describe the same relationship. So an example would be 2 to 3 and 4 to 6. So again, we can get the 2 to 3. It actually is equivalent to 4 to 6 just because we can multiply by each of those numbers by 2. Example 1 is completing ratio tables. All right, so pay attention to, this is example 1, but pay attention to the directions because the directions really are important, especially when we do your checkpoint. So it says find the missing values. Let's get this out. So find the missing values and then write the equivalent ratios. So an example of what this would look like is we have this ratio table here, and this is right from your book. What we're going to do is we're going to figure out how do we fill in these missing numbers here. Some ratio tables you'll end up doing, you'll add or you'll multiply. And on this one, you can kind of see the pattern that takes place. And let me change it over here. So I go from 1 to 2, and we just simply add 1. Well, whatever I do in the top, I'm going to continue doing on the top when I'm adding. So now I'm just going to add 1 more here, which 2 plus 1 equals 3. And then you can see if I add 1 more, I end up with 4. So I'm going to do the same thing on the bottom. If I'm going from 3 to my next one, I have to recognize that I've got a 9 coming up. So this 9 kind of tells me that I've got to go in multiples of 3. If I were to add 3 right here, I would become a 6. And then if I did the same thing, I'll get to my 9. So you have to use numbers that are there to kind of guide you. If I'm going to do it there, I'm going to also do it here. And 9 plus 3 more is 12. So now that I have my numbers that I put into my ratio table, I'm just going to simply rewrite them out because I'm going to do what it says to do here, then write the equivalent ratios. So what I would look for an answer would be just simply this. I'm talking about triangles to sides. So my ratio from triangles to sides would be 1 to 3, comma, 2 to 6, comma, 3 to 9, comma, and 4 to 12. And I just simply got all those numbers from this. Triangles 1 to 3, 2 to 6, 3 to 9, and 4 to 12. They came right from my ratio table. These are all comparing triangles to sides. I realize we don't have any work that says what are triangles to sides, but we're just trying to see how we can make equivalent ratios out of them. All right, let's look at this next one. So now we have a comparison of frogs to toads, and they give us the ratio of 4 to 6. So I'm going to start with writing that down as my answer. So remember, we're going to write out our equivalent ratios too as the answer because that's what our directions say. So I'm going to put 4 to 6. I know I already have that. I know my next one will be 20 to something, okay? And that's what we have to figure out kind of next. So if I have 4 to 6, I've got to look at the relationship I have next. I've got this spot here missing, but I do have this 4 that goes to 20. Because I know that at 4 goes to 20, I have to figure out how did I get from 4 to 20. We're not going to do addition here. We're going to do multiplication because we have larger numbers. So 4 to 20, I know if I multiply by 5, 4 times 5 equals 20. Remember, with multiplication, these can be different. They don't have to be multiplied by 5 each time. However, what you do need to make sure when you multiply ratio tables, whatever I do to that first one up here, I have to do to this one down here. So I'm going to also multiply that by 5. It's kind of like equivalent fractions. It's kind of the same thing. 6 times 5 equals 30. which tells me my answer for that one. So now I have a 20 to 30 ratio. Now, if I'm going, I've got to figure out what do I got next, but I don't know what I'm multiplying these two by. But the clue shows us that we have 90. How did I get from 30 to 90? 30 times what gets me to 90? Well, you should figure out that 30 times 3 equals 90. So I'm going to multiply my top by 3. 20 times 3 ends up being 60. So my next equivalent ratio is 60 to 90. Drop my pencil, sorry. So then I've got 90 and it goes to 180. And up here, I don't know what it is. So I've got to figure out 90 times what gives me 180. We should know that it's 2. And again, you can divide that. 180 divided by 90 if you needed to. But it should be 2. So I'm going to do the same thing up here. 60 times 2 equals 120. So now my last ratio is 120 to 180. This would be my final answer on a question like this. Go ahead and try this one, and then I'll go ahead and pause it, and then I'll put in the answers. One little hint, you're going to use addition for this one because you can kind of see the patterns. And then I'll give you one more with multiplication. Remember, when you're dealing with addition, these will all be the same, and these will all be the same, okay? That's the difference. So I added 4 on the top, and I added 2 on the bottom. It's a little bit different when it comes to multiplication. You also need to write out the equivalent fraction, ratios, which would be a 4 to 2, comma, 8 to 4, comma, 12 to 6, comma, and 16 to 8. And this would be your answer. All right, this one is miles to hours. And again, the hint is that you're using multiplication. Go ahead and pause it and then give it a try for the answer. And here's your answer. Just as a reminder, when you're multiplying, you're starting with what you know. You've got a 3 and you go to a 6. So 3 times 2 equals 6. So that's why we do it there. And then we do the same thing up here. One thing to remember as you're working with this is this side and this side, they don't have to be the same anymore. But what needs to be the same is what I do here and what I do here. So this doesn't have to be the same, but these two do. So as you can see the patterns, and then this would be your final answer. Something important to note before we actually get into example 2 is please write down these couple of things about how you can generate a ratio table. Just copy this down real quick, that ratio tables can also use division or subtraction to complete. Adding or subtracting, multiplying or dividing can all be used to solve ratio tables. All right, this one is going to be the same as the last two, but it's an example 2. We're going to do this a little differently, though, because you're going to see different patterns that you need to pull out in order to solve these. So we're going to start with looking at, we have a ratio of 1 to 100 dollars to cents. So now you need to look and see, okay, how did I get from 100 to 300? Well, you just multiply that by 3. So again, we're going to do the same thing above. 1 times 3 is 3. So my next one is 3 to 300. Oops, let me redo that. To 300. And then we need to look at the next known number, which happens to be 900. And we can say, how do we get from 300 to 900? And we can multiply again by 3. Do the same thing up at the top. So 3 times 3 is 9. So now I have a ratio of 9 to 900. But now I have something kind of, it doesn't really work out very well. I go from 9 to 8. So in order to figure out how to get from 9 to 8, I have to go back to subtraction instead of doing multiplication. So I'm going to subtract 1 from the top. And remember, if I do that on the top, I don't have to necessarily do it the same to the bottom because that won't necessarily work. But I'm going to do it in a power of 10 in this one. So I'm going to subtract down here 100, because if you notice the cents are in 100, so 900 minus 100 gives me 800. And if you think about that, it actually makes sense because they're talking about dollars to cents. $1 equals 100 cents. $3 equals 300 cents. $9, 900, and $8, 800. So you got to look at what they're asking too, and that can kind of help you with your patterns. All right, let's try this one. So now this one gets a little bit different too, because I'm going to use all kinds of different things to get to what I need. The first thing I'm going to look at is from 1 to 2. And 1 to 2, I'm going to actually multiply this one instead of adding this one. And I'm going to multiply it by 2. 1 times 2 is 2. So I'm going to do the same thing up here. 3 times 2 is 6. Now I go back to 2. That's my next thing that I see here. Well, I have to look at 6. How do I get to 2? Well, in this one, instead of subtracting, another easier way is to divide it. 6 divided by 3 gives me 2. 2 divided by 3, because you got to do the same thing when it comes to multiplication and division. This one's a little trickier. I have 2 divided by 3. That's kind of funky, so I'm going to make that into a fraction. 2 divided by 3. So now when I get to looking at my next couple, I'm going to look down to here, and I'm going to see how do I get from 2/3 to 5/3. For this one, you got to kind of think outside the box here. I need to know what 5/3 equals as a mixed number in order to figure out how do I get from 2/3 to 5/3. Well, 3 goes into 5 one full time, and if it goes in there one full time, 5 minus 3 is 2, and I leave the same denominator. So now I'm just going to change this for a second to 1 and 2/3. How do I get from 2/3 to 1 and 2/3? Well, I just simply add 1. So that gets me there. Now up here, I've got to look at how do I get from 2 to a number that's equivalent to that. All right, so now I'm going to actually erase this and keep it at my 5/3 so I can show you how to do the adding up here. All right, so the first thing is you got to do a little extra work down here. I'm going to look at this for a second because that's how I'm going to get to this number here. If I've got 2 over 1, which is what this equals, it's a ratio to 2/3, okay? So that's important here because now I have a 5/3 right here, and I'm trying to figure out what this fraction would be. Now, what pattern you notice here is I went 2 to 2, okay? Obviously, my denominators are different, but my numerator is not. So I have to figure out how to get this to be a 5 over 1 so that these stay the same like these two are. That will keep it equivalent. So now 2 plus what gives me 5? Well, I just have to add 3 more. So my answer on the top there will actually be 5. But this is the work you have to do to figure that out. My total answer for this problem will be 3 to 1, comma, 6 to 2, comma, 2 to 2/3, comma, and 5 to 5/3. So this would be what the answer would be if you were writing it out on a test or checkpoint or something like that. And this concludes the 3.3 video. There will be a second one that will help you along the way, but we'll start here.